Hello everyone, in this lesson we will talk about centroid of a solid of revolution. A solid of revolution of constant density ρ has its centroid on its axis of rotation. So this concept is very important because we are working with a solid. That means that you are going to have an area revolving about the x-axis or the y-axis to form a solid. In the in the way that you are finding volumes, okay? So in finding volume, you need to have the x-axis or the y-axis identify to certain problem that you are working with. Okay, so in this case, what I'm going to do is I'm going to ask everyone to examine the solid that I have here. So I am going to find the centroid for this solid, but in order for me to find the centroid for this solid, I'm going to project it onto a Cartesian plane. So let me draw the x and y axis so that I can demonstrate for everyone how important it is that you have to identify and place the solid on certain axis of rotation. Okay, so I am going to draw the x-axis through this. Okay, I think it's a bit crooked. So let me do it again. Alright. Okay, so it's pretty good now. So it's the x-axis, and I'm going to draw the y-axis as well. Okay. So I have a disk. So let's write it as the y-axis and the x-axis. And I want everyone to concentrate on this disk that I have. Okay, so here's the disk, and we are having a fuse in here, right? So we're having this as well. And on this, what I'm going to ask everyone is to pay attention to this part. Okay, so this is one of the element that I'm going to use, which is the vertical element. And this one I'm going to call is dx. Okay, and from here to here this is A. And this point, I'm going to identify this here as B. Okay, so I would like you to take a look at this function here. This function that I have. Okay, so that is the function, and the area that I'm working with will be this one. Okay, and I'm going to highlight the area for everyone. So I just want to find the other. Okay, so I'm going to revolve this one about the x-axis. Okay, so in this case, the axis of rotation is the x-axis. So if I have the axis of rotation is the x-axis, then you can figure out the other ordinate right away. So which is y should be equal to 0. Okay, because the centroid should be around in here somewhere, and it should be on the x-axis itself. So if the value is on the x-axis, the other ordinate for y should be equal to 0. Okay, so in finding the centroid of a solid, then what you need to do is you need to identify the area, but to make sure that your axis of the rotation is given to you. Or if you want to place something, you want to design something, and you want to keep it stabilized, you have to find the central point for it as well, right? So in this case, the best is to project it on the x-axis or to project it on the y-axis, and you rotate the area about the x-axis or the y-axis. Depends on what axis of the rotation that you have, you can figure out your centroid. Okay, so in this case, my axis of rotation is x-axis, so I'm going to find this x bar, and I know that the value for y bar should be equal to 0. So let's derive the formulas. Alright, so deriving the formulas, I would like everyone to recall a formula that we have. If I want to find a mass, okay, I will have to have the density of that material. So the density is equal to rho, okay? I multiply by the volume of that mass. I will have the values for the mass, okay? So find the volumes of the object, multiply by its density will give you its mass. Okay, so take a look at the disk that I have here. So here's the disk that I have. I've drawn a vertical disk. Okay, if I draw a disk to find volume, that means I am using the disk method, right? So if I use integration, that means I have to find I have to add up the sum of all of this disk in terms of integration, right? So to find the volume of this solid, okay? And the volume for this solid, that means I have to identify the area. So from here to here, I would like everyone to note this equal to y. I will let this here equal to y. That means the radius of this circle right here on this disk will be equal to y. Okay, so I will put y is the radius of the disk. Okay, then area will be equal to pi r squared. Is that right? Okay, area is pi r squared. So I replace the r by the y because I let the radius equal to y. Okay, so now the volume will be equal to pi y squared, and I multiply by dx. Okay, so this is dx is this part of the disk. Okay, so this is very important. Okay, this is actually very important. Now I'm going to substitute this into this formula so I can find the mass. So now m is equal to rho times the volume, which I already have. So I multiply this with pi y squared dx. Okay, so let's circle this one for now. And I'm going to ask everyone to recall, okay, what x equal to. Okay, in previous lesson we have x bar will be equal to my. Okay, so the sum of all the moment about the y-axis, but divided by the area. But in this case, what I'm going to do is I'm going to ask you to divide it by the mass. Okay, so mass is for the m. Okay, so what is my equal to? Okay, I will have my is equal to the mass times the distance. So in this case, I should have the mass. I found it as rho times pi times y squared dx. Okay, and I multiply the distance. So I'm going to identify the distance for everyone from here to this mask, and from here to this distance I'm talking about is identified as x. Alright, so that means I will multiply by the distance, which is x in this case. Alright, okay, so my is the sum of all the moments. Okay, my is the sum of all the moments in terms of the sum because of this function shape like this. Okay, I am going to write this equation for everyone. Okay, so my now equal to the integral of pi rho y square dx and x, right? Okay, so let's rearrange this. Pi is a constant, rho is a constant, so I can bring it across the integral sign. So I have pi rho integral of x times y squared dx. Okay, so x is a variable, all right, and y is a function, y that I have here for everyone. So this is the function y. All right, so function y in this case, it will be in term of x because you integrate in term of dx, and we need to find the value, so we need to put in here our upper and lower limit to so that we can use a fundamental theorem. So in this case, I have a and b. So from a to b, that's what I should have. All right, okay. So continue on with this formulas. I am going to ask everyone to remember that I identify mass as rho times volume, right? So here is equal to mass rho times volume. Okay, so let me write these formulas. The side here is x bar equal to my divided by the mass. Okay, so I'm going to derive this mass for everyone in a second. So now, mass in terms of integral will be equal to m. Okay, excuse me, sorry. Okay, in terms of the integral is pi times rho, the integral of y squared dx. Okay, from a to b. Okay, so now you see that x is equal to my divided by m. So I'm going to take these two divided by each other. Okay, so I'm going to write it in here. So x bar equal to my, which I already found right here. So I'm going to put this pi rho integral from a to b of x y squared dx. And what is the mass? The mass is equal to pi times rho, and the volume in this case is the this method. So I should have this equal to pi rho integral a to b of y squared dx, and these two will cancel out because they are constant. Therefore, my x bar formula will be equal to my divided by m. So in this case, will be integral from a to b of xy squared dx divided by integral from a to b of y squared dx. Okay, and please do not cancel out the x squared because it's just a variable for this integration, and you have to integrate, find the values, and divide one into the other. Okay, so these are the formulas that I actually summarized for everyone. Okay, so in these formulas, if you are going to find a centroid of a solid and its axis of rotation could be given to you, if it's the x-axis, then you know that the y bar will be equal to 0, and this is the formula that you are going to use. Okay, so in this case, you are going to use the vertical element. So if you have a centroid of a solid revolution with the axis of rotation is y-axis, then the value for x bar should be equal to 0, and in this case you are going to work with the horizontal elements. Okay, so again, horizontal element for the this method, the vertical element with the this method, and then the my mx we already figure out up here as to why we have to use this formulas. All right. Okay. Okay. So let's work with a few examples. So in this lesson, I will have two examples, and I don't think I will cover both examples in just this one video. So I'm going to work with example 1, and then for example 2, I will continue with the next video. Okay, so basically, if you are finding the coordinate of a centroid, then the first thing you are going to do is you take a look at what axis of rotation is given to you. Okay, so the axis of rotation, if it's given to you as the x-axis, then right away, what you want to do is you know that the y bar will be equal to 0, and then write down the formula that you have to use. So the x bar will be equal to my divided by m, which is the integral from a to b. And you know that if the axis of rotation is the x-axis, and you are going to use the vertical element, so x times y squared dx divided by volume using this method, so it will be y squared dx. Okay, so what I'm going to do is asking everyone to shade the area again. Okay, so it's very important. And then identify the upper and the lower limit as well, and what element that we are going to use. So in this case, we are going to use the vertical element. So this is x squared as a parabola. X squared as a parabola, and x equal 2 as a straight line. And then the y equal to 0 is the x-axis, so this is the area that I'm working with. Okay, and here is my element. Okay, so what function am I going to use in this case? Okay, so this one is y equal to x squared. Okay, the formula said that I have to have x times y squared. So what you want to do is you are going to square this y. So y squared equal to x squared, all of it square, so we equal to x to the 4. Okay, so we can just find this in one step. All right, okay. So let's do this as well. It's the x-axis and the y-axis. So the axis of rotation is the x-axis. Okay, so I'm going to write down x bar will be equal to integral from, okay, so make sure we do that all at once. Okay, so now let's figure out our upper and the lower limit in this case. So right here should be 0, and right here should be equal to 2. Very simple. Okay, so the a is equal to 0, b is equal to 2. So I will write from 0 to 2 x times y squared, so x times x to the exponent 4 dx, and this is from 0 to 2 as well, and then y squared, right? So this is the formulas that we are going to use. Okay, x times y squared, x times x to the exponent 4. Right here, I just have x to the exponent 4 dx. Okay, I'm writing both of them, the numerators and the denominator at the same time, to show you that it's the integral that we have to work with. And we cannot cancel anything here. So the integral from 0 to 2, I should have x to the exponent 5 dx. And this one, the integral from 0 to 2, so it's still x to the exponent 4 dx. Okay, so the integral of this should be 1 over 6 x to the exponent 6. Evaluate from 0 to 2. The integral of this should be 1 over 5 x to the exponent 5. Evaluate from 0 to 2. Okay, so now my x bar will be equal to, so now you know that this should be equal to 0. So the f0 is equal to 0. f0 is equal to 0 in this case as well. So I should have, to be clear, I will put 1 over 6, okay, 2 to the 6 minus 0. I should have 1 over 5, 2 to the 5 minus 0, okay, and I will have 1 over 6 times 64, and I should have 1 over 5 times 32. I should have 64 over 6 divided by 32 over 5. So in this case, I should have 64 over 6 times 5 over 32. So I should have this as 5 over 3. So this and that, this, that, I should have 2 over 3. That should be 2 here, and 2 cancel with that. I should have 3. Okay, so then my final answer should be 5 over 3. And I just want to remind everyone here is that the f0 equal to 0. So we don't have to worry about that. So now the centroid is equal to x bar and 0. So that means I will have 5 over 3 and 0 as the centroid for this particular solid generated by this particular area, and the axis of the rotation is the x-axis. Okay, so you see the area is still involved. You take the area, you rotate about the x-axis, and apply the formulas to find the mass, and apply the formulas to find the my, divide one into the other, you have the centroid of this solid generated by the area. Okay,